Okay, so our diencephalon's a little bigger. So if you have room, like I'm going to write some of them down in this area. We'll start with our thalamus, because that's going to be the middle ground. Thalamus, epithalamus, hypothalamus. Thalamus is just going to be our first sensory input center. So all sensory input is going to come to our thalamus. So this would be the classic example of, I took a psychology class, just like the 101 or whatever it was, and the professor started out the class, he was wearing a green tie, okay? Then I took it at a night class, so it was like, you know, that 3-hour one. Like, all right, everybody go get a drink or go whatever you want. So then 10 minutes later we come back, and then he continues on with his lecture. He's talking for 30 minutes, and he says, does anyone notice something different about me? And everyone says, no. And then what ended up happening is when he let us all break, he put on a red tie and a suit coat that he wasn't wearing before, but no one noticed. Why? Because just because sensory information will come to our thalamus, that isn't necessarily our brain says, ooh, let's store that information. That's important. So I'm wearing a pink or whatever color shirt. If that's not crucial to your life, I could probably leave, or like later on today, pass you in the crossroads and be wearing a navy shirt, and you're not gonna be like, oh, she changed shirt. But it'll come to your thalamus, like right now you recognize it's the color shirt I'm wearing, but it doesn't necessarily mean we're gonna store the information. Okay? We also call the thalamus the synapse heaven. So every ascending track. So let's say I'm trying to send, of course, sensory information, action potentials. Maybe, oh, my phone screen is a little cold. So I'm going to transmit action potentials going up to my spinal cord, up here, passes through my medulla oblongata, goes to my thalamus, and is going to synapse there within the motor one to then say, let's move my hand, that's kind of cold. So the thalamus, we can call it synapse heaven. Because all ascending tracts will synapse there. So we understand what's going on. Okay. We'll do epithalamus next. Epithalamus, we can divide it in two different categories. Category numero uno would be your pineal gland or pineal body, whenever floats your boat. And then your Ben, you are so funny. Habenula. Nah. That'll tie in later, I swear, I'm not just an idiot. So you have your pineal body and your habenula. I'm glad you think I'm funny sometimes. Okay, so our pineal body is going to be what secretes what? Melatonin. And you want to take melatonin in here? And your roommates do, husbands? Melatonin is what we call the sleeping drug. Helps you go to sleep. My roommate, Hannah, she always takes melatonin before bed. Basically makes you fall asleep, which is good. We kind of need sleep. So, oh no, I forgot his face. This is my brain. When the lights go out at night, it gets darker. That's when we send our epithalamus to then go to our pineal gland to say, okay, start secreting melatonin. To do what? Fall asleep, right? But, oh, actually, that's one more thing first. So melatonin has two things it does. Number one, it has antioxidants, which is good. That prevents cancer. And number two, it delays the onset of puberty. Okay? So kind of take a moment to think about this. If melatonin delays puberty, and melatonin is secreted when it's night and we don't have light, would it be a good thing or a bad thing for a 10-year-old to always be staying up late, playing video games, laying in bed texting on his phone with a bright light? Is that good or bad? Bad. Why would it be bad?
Would puberty start earlier?
Right, it would start much earlier. Because if he's not getting the blackout signals, meaning secrete melatonin, so let's say his eyes are still open, he isn't going to be delaying puberty. So maybe he'll hit puberty at age, what did I do? Did I do 10 or 11? Let's say he starts at 12. So do you think now in today's modern world, so 2014, we'd have a faster puberty in youth than there was 50 years ago? Yeah, why? Big thing for technology and sleep. Yeah. So that's kind of a fun application question that they can ask. Okay. And then we have our, Ben, you are so funny. So I have a friend named Ben, and he's funny. And I was going to tell him something, but then all of a sudden I smelled something. I smelled my grandma's, or I didn't smell my grandma's, I smelled cherry pie, and then I thought about my grandma. Okay? So habenulate is going to be when we have olfactory translates into us remembering a memory. So, Ben, you love, because then you go to La La Land because you're thinking about grandma's pie and it's so good. Or if you walk by a guy in class and you smell his cologne and you think of your ex-boyfriend in kindergarten who hopefully wasn't wearing cologne, that would be your habenula. That's what's going to trigger, oh, I smell something and I remember it from another place. That's your habenula. Okay? And then I'm actually, tell me when you guys have got this down, because I'm going to erase just this part. Good? Okay? So that was epithalamus. So we have pineal, habenula. Okay? Hypothalamus. Hypothalamus does what? Do you remember? Hypothalamus is going to maintain. We can kind of do two categories again. Maintain homeostasis. What does homeostasis mean? Yep. Normal. So the normal set point or the normal range. Way back from, I think, chapter 1 or 2. Homeostasis. As well as regulate endocrine functions. What does endocrine mean? Basically hormones, different secretions, chemicals, things like that. Okay, so when I think of the hypothalamus, I think of a hippo. Hippo. So, okay, my hypothalamus. What does a hippo enjoy doing in life? Well, it's really fat, so we can do hunger and thirst, which is homeostasis, right? So if someone in this room hasn't had anything to eat since 11, right now your hypothalamus would be telling your brain, transmitting signals, time to eat, things like that. As well, of course, your digestive tract, things like that. Hunger and thirst. Regulate body temperature. So it's 100 degrees out, and the hippo's like, I'm just going to go crawl in my water hole. Regulate body temperature. Endocrine functions. Hippos are pretty big, right? So that's where we get our growth hormone. As well as our thyroid hormone. And that's your hypothalamus.